Alright, so here is the content of the lesson that you missed. So if you guys are listening to this recording, it will be a slightly more intense recording than usual because I don't have anyone here to ask me any questions. So I'll just go through the main content. And your job is to understand as much as you can and then try out the exercises that I mentioned in this recording, and work through the exercises along with me as well. Okay, so 19A is about tangents and normals. So the concept of normals depend on the school. Some schools will not teach the concept of normals, but tangents, everyone will have to learn this. So you guys have learned before that given a certain graph, the tangent of the point, right, is the line that goes through that point and barely touches the curve at that point. So let's just say that we have a very basic graph, x squared, right? And this point could be x equals 2 and y equals 4. How did I get that? Well, when x is equals 2, right, this equation is y equals x squared. When you sub the value 2 into the x here and you calculate for y, then y would be 4, right? So y would be 2 squared, which is 4. So that's how I calculated y. Okay, so the point is 2, 4. Now, the only thing you need to remember for the tangent equation is that, so this is the tangent equation, right? The tangent equation is y minus y1. And I'll explain it in a second. Equals to the gradient times x minus, I'll put the gradient in red, minus x1. Okay, so the values in red are what you need to actually find out in order to plug into this tangent equation and get the equation of the tangent. Okay, so what are the values of x1 and y1? So gradient, you all know what the gradient is, right? The gradient is the value of the derivative, is the derivative at x at a certain x value. And look, this is actually the derivative at the when x equals to the x1 value. So in fact, let's say we want to find the tangent, because the tangent to the curve must be coming from a point, right? Like if you have this point, then this is the tangent, and if you have this point, then this is the tangent. You can't have a tangent that doesn't touch a point. That doesn't make sense. This is not a tangent to the curve. And so the point where the tangent touches the curve, for example 2, 4 in this case, this is your x1 and y1 point. Okay, so given this point, in this example, x1 would be 2 and y1 would be 4. Okay, so x1 is 2, y1 is 4. So if we were to plug it into this tangent equation, we would have y minus 4 is equals to gradient times, and I'll write gradient in a different color, equals to gradient times x minus 2. Okay, now we just need to find the gradient, plugging into this equation, and then we get the tangent equation. So how do we find the gradient again? So we need to first find the derivative. Okay, so find the gradient. So we got y equals to x squared. So then we calculate the derivative, dy over dx. Alright, this is the basic one. Bring the power down, drop the power by 1, so that will be 2x. And at x equals 2, at this point, the derivative would be equals to 2 times 2, which is 4. Right? So this is literally what the gradient is. Okay, so we plug that into the equation one more time. We put that value in here. Then the final equation would be y minus 4 equals to the gradient, which is 4, times x minus 2. And normally you want the y equals mx plus c format for any line. So you would want to bring this over there and expand the brackets by distributing the gradient into that. Right, now this would get us y equals to 4x. So I'll open the brackets first, 4x, and then minus 8. Bring the 4 over, I would get plus 4. So then I would get y equals to 4x minus 4. Okay, this is the equation of the tangent. Let's test that out in Desmos to see if we are correct. Okay, I have prepared a little graph here, and this is the graph of y equals to x squared. Right, see y equals to x squared, that's the graph there, and then this is the point that we're talking about, 2, 4. Right, x equals 2, y equals to 4. So let's put in the tangent equation that we just found, y equals to 4x minus 4. That is the perfect tangent line at this point here. Okay, so that's how we find the tangent line at a point. Actually, we can find the tangent line at any point using that formula. All right, back to the concept. Now I'm going to use example 1 from a textbook to show you guys how we actually write it. So note that what I was explaining up here was mainly to explain to you guys the logic behind the tangent equation. But when you want to write in the actual exam, it's not going to be this long. Okay, it will be a shorter version. So let's see. We know the formula is y equals. We know this formula, y minus y1 equals to the gradient times x minus x1, right? We know this formula, so we're not going to write the formula first. We'll write it later. So we know that at the point x equals to 1, so we just write x1 equals to 1, okay? And then we write the value y1, and that's just simply substituting x into each of the values here. So that will be 1 cubed plus 1 over 2 times 1 squared. So that will be 1 plus 1 over 2, which is 3 over 2. Okay, so x equals to 1, and then actually I'll write this y1 in the next line so I can box that up, equals 3 over 2. So now we've got these two, and then we'll write dy over dx. So we need to calculate the gradient next. Remember, x1, y1, and the gradient. So find the derivative equals to 3x squared plus 2 times the half is just 1, and drop the power by 1, that will just be x to the power 1. Alright, and then at x equals to 1, then you write dy over dx, and substitute the value 1 into that. That will be 3 times 1 squared plus 1, which is 4. Okay, so then if you have some space, you would continue, but I'll just write it over here. So the tangent is equals to y minus y1 equals gradient times x minus x1. Okay, and then we just sub the values in at this point, and we already know what everything is. So that'll be y minus 3 on 2 equals to the gradient 4 times x minus x1, which is 1. Right, same thing, expand the brackets, 4x minus 4 plus 3 on 2, and then y would be equals to 4x, and then that turn into minus 8 over 2 plus 3 over 2. So y is 4x minus 5 over 2. And that is it. Okay, and here we are again on Desmos, and you can see once again that in this equation, y equals to x cubed plus 1 over 2 x squared, which is the red line there, yeah, and this is the point 1 3 over 2. That's a point 1 3 over 2. Then the tangent line we just found, y equals to 4x minus 5 over 2, is the exact tangent line at this point here. Okay, which is the blue line. Alright, so that's how you find the equation of a tangent. So note that the math behind this is not hard. Okay, the math behind this is actually quite simple, but remembering this and knowing when to use this in the exam is going to be the challenging one. So the basic skill you guys need to do is actually just to do all these questions, like remember how to do these formulas by heart, so that when it comes to the exam, you can actually work through it in the exam. Okay, now your task is to work through these questions here. Just one ABCD, right? That's it. That's all you guys need to do. I'll check you on that, and then you need to upload your answer onto the group chat as well. Just note that find the equation of the tangent, not the normal. Okay, so ignore this one. Just find the equation of the tangent at these given points, right? For this equation A, B, C, and D. Work through that and send out on the group chat. I will resend the instructions later as well. And that would be the end of chapter 19A, tangent. All right, let's move on to 19B, rates of change. So there are only two main concepts in the rate of change chapter: the average rate of change and the instantaneous rate of change. Okay, so average rate of change, or AROC, right? Instantaneous rate of change, which is IROC. That's a short form for these two. So AROC, the average rate of change, is the idea that between 2 points. So the only difference is average rate of change is talking about the rate of change between 2 points, and instantaneous rate of change is the rate of change at 1 point. That's it. Okay, so if you have a graph that goes through, say, these 2 points here, right, what's the average rate of change between the 2 points? Well, this is just your rise over run. As simple as that. It's like saying, okay, from home to school, right? From home to school, those are your, this is the graph of your speed from home to school, and they want to you to calculate the average speed, and that would just be, you know, like the final between 2 times. So that just be the speed at the second time when you get to school, and then the speed when you just left home, right? So that would be the average rate of change. Now, instantaneous rate of change, as I said earlier in the last few weeks, this is the same as the derivative, right? Or also the gradient. All these concepts basically refer to the same thing, and that is, so this one is the gradient at a point. Okay, the gradient at a certain point is the instantaneous rate of change, because let's say for the same graph between home and school, if you're talking about like at that point there, what is your speed at exactly that point? You know, when you drive, the speed will fluctuate, right? It will be like 58, 60, 61, but at any point you have a specific speed. And so the speed at that point in time is the instantaneous rate of change, or also the gradient at the point. Okay, so average rate of change is the idea of rise over run, rise over run. And what's rise? Well, if you have this equation as fx, right, the run is simple. Let's just say we have 2 values, that's x equals b, x equals a, then the run would be the second x minus the first x. So what's rise? Rise is the y value at point B minus the y value at point A. But we have a function fx, so the notation will turn into f of b minus f of a. And that is effectively that formula up here. Okay, that's just essentially rise over run. fb is just the y at b, and then fa is the y at a. Okay, that's all it means. And b and a are the 2 x values, and that would be your rise over run formula. So the instantaneous rate of change is the same as the gradient, which means that is just, so the IROC is essentially f dash at, let's say that's the point A, right? F dash at the point A. That is it, right? In other words, you sub x equals A into the derivative. That's it. Okay, let's go through an example here. So first they ask us the three questions. The first one is the average rate of change, or the AROC, for x between 2 and 3. So same thing, we have like, this is the quadratics, and then x between 2, right? X between 2 and 3. They want the average rate of change between the 2 points. Okay, so that would be simple. So f of 2 would be 2 squared plus 2 times 2, which is 4 plus 4, which is 8. And then f of 3 would be 3 squared plus 2 times 3, that would be 9 plus 6 is 15. Okay, so the average rate of change, AROC, would just be, always write the formula, f3 minus f2 over 3 minus 2. So I like to write the formula to know which value I sub in first. I've seen so many students, they don't write the formula, and in one of those rainy days, they would swap it around. And if that rainy day is in the exam, GG. Okay, so write this, then you know, oh, f3 is that one first, right? So 15 minus 8 over 3 minus 2. Note that the rate of change is not always going to be bigger number minus smaller number. Okay, and you see in a few, examples that some of them, the average rate of change could be negative, and that's because it's going down. If you're talking about, let's say, the same graph, but from this point to this point, it's going down. So the average rate of change would be negative. It's similar to a negative gradient. Okay, anyway, so that would be minus 7. That would be, sorry, minus, it would be 7 over 1 in what? That would just be 7. Okay, so normally it's units per, there will be some sort of unit like meters per second or something, but there's none for this one, so you just leave it as it is. And then question B, average rate of change for the interval 2 plus h. So same thing, we already have got f2 here, so just f2 plus h is 2 plus h, everything squared, plus 2 times 2 plus h. Okay, so then the A rock would be f of 2 plus h minus f of 2 over 2 plus h minus 2. Does that look familiar? It should, because this is the formula for calculating the derivative. And to calculate the derivative, you find out what happens when h gets closer and closer to 0. So that'll be 2 plus h, everything squared, plus 2 times 2 plus h over h. Okay, so for this question, they don't ask you to do anything to it, so you just leave it as it is. And then the last question, C. Okay, instantaneous rate of change when x equals to 2. So we need to first find the derivative, f dash of x. Simple question will be 2x plus 2, 2x plus 2. And then you find the derivative at the x value 2. So that will be 2 times 2 plus 2, which is 6. And that is the instantaneous rate of change. That just means that at the point 2 here, the gradient of this, of the tangent line, right? The gradient will be equals to 6. And you see how this one links to the previous concept, where if you find the gradient and you put into the tangent equation, you get the tangent line. Okay, all right, so that's example 3. All right, next we're moving on to an actual application question. This is something that is very likely what you will see in the exam. A balloon develops a microscopic leak and gradually it decreases in volume. So note that it's decreasing in volume. So you would get negative values for the A rock and the I rock stuff here. Okay, so you got V equals to an equation of T, right? And note the units. You need to include the units in the answer as well. The rate of change of volume after 10 seconds. So when you see the rate of change, right, after 10 seconds, what they're saying is at 10 seconds, what is the rate of change? Okay, so at 10 seconds, and remember when you see that, like when you see that, that means at 10 seconds. Sometimes it will be like, oh, between 10 seconds and 20 seconds. That's different. That's the average rate of change. But they're asking at 10 seconds, what's the at 10 seconds, what's the rate of change? And because it's at one point, remember when it's at one point, you have the instantaneous rate of change, right? Because the average rate of change is between 2 points, rise over run. But the instantaneous rate of change is the gradient at the 1 point only. Okay, only 1 point. So we have only 1 point at 10 seconds. So for question A, first you need to find the derivative. So we'll derive V. Remember, V is the main variable, the Y variable, with respect to T. So dV over dt. And that will be equals to 600 becomes 0, minus 10t becomes negative 10. And then this thing times the power down, that will be minus 2 over 100, which is 1 over 50 t. Okay? Okay, and then for at A1 at t equals to 10, as t equals to 10, then dv over dt equals to minus 10 minus 1 over 50 times 10, right? So that would be minus 10 minus 1 on 5, and that would be minus 50 minus 1 is minus 40, minus 51 on 5, or minus 10 point something. Okay, so the unit is, rate of change is centimeters cube per second. Alright, similarly at t equals to 20, then you calculate the dv over dt, and and that will be minus 10 minus 20 over 50, which is minus 10 minus 2 on 5. That'll be minus 50 minus 2 minus 52 on 5 centimeters cubed per second. Right, that's it, and that's for A2. Okay, so that's very simple, right? It's just calculating the derivative and subbing the values in. Now the tricky one would be question B, where you ask for how long could the model be valid. What does that mean? So this is the model for volume, right? And when you think about it, you need to analyze what kind of equation is this. This is a quadratics, right? So a quadratic will always have a shape of that looks something like that. Okay, it's a parabola. This is upside down parabola because the sine of p squared is negative. Okay, upside down parabola means that it will keep going. At some point, it will cut through the x-axis. But does it make sense for a volume to be negative? No, the answer is no. So you need to actually find when the volume would be negative, and that would be the point where the model is no longer valid. Okay, and I'm just going to use the textbook example answer here and walk you guys through that. So as I mentioned earlier, the model is not valid when V is less than 0. The volume can't be less than 0. The minimum volume you'd get is just 0. Right? So then when you need to sub volume equals to 0 into the equation, and then normally you would want to do that. You won't actually do that. It'll just be using graphics calculator, right? Using graphics calculator, most likily NSolve. Just NSolve that equation, and you would get t equals to these two values, and then you would reject. You would write reject it for this value as t must be more than 0. So then the final conclusion is, you don't need to write all of that stuff. It will just be a final conclusion. A model is valid when 0 or less than t less than 56.78. So because at that point 56.78, the volume equals to 0. Yeah, that's what we were finding over here. So at that point the volume is 0, and after that it's not valid anymore. It doesn't make sense to calculate the rate of change when the volume is just simply 0. There's no more changing. Okay, as homework before the next lesson, you guys need to do these two questions here. All right, question 2 and 3. It's like the same thing. There's no difference. Yeah, there's no difference. Just work through these questions. All right, and then for question 3, this is the interesting one. Find dr over dp and explain what it means. Alright, so try to give an explanation. So this one is very important for you to actually try to write down the explanation, because that would help you understand the concept of rate of change a little bit better. Everything else is just calculation. And another interesting one is question C. For what selling prices is the revenue rising? So when you derive it, so note that this equation is once again a quadratic. So when you derive it, you get a linear equation, right? For what selling price is the revenue rising? This means that the rate of change, the R over dp is more than 0. Because remember, the rate of change is it's literally the rate of change of the revenue over price, right? So the revenue is rising means that, and that also means the gradient, right? So if the revenue is rising, means the gradient is more than 0. Okay, so this graph would be something that looks like that. All right, and most likely it will be this graph here. That's my bet. You will see if I'm correct or not. Most likely it will be this graph there, and then the revenue is rising from around this point. Right, it's still rising, and after the top it starts decreasing. So the revenue will be rising from between these 2 points here, right? Wherever the first point is and the maximum point, right? That's when the revenue is rising. And I'll give you a hint. At the top point is when the gradient equals to, so the gradient at the top point will be equals to 0. That's how you find the x value of the top point. Okay, give that a try, and then I'll go through these questions. Most likely I'll go through these questions in class, but I want to see you guys attempt these questions at home first. All right, good luck.